The propulsion of electric cars EVs is about to undergo a radical change in the automobile industry. The solid-state battery, a groundbreaking technology that will improve EV performance, safety, and sustainability, is at the center of this change. We'll go deeply into the development of solid-state batteries in this video, examining their definition, significance, difficulties, and potential to revolutionize the design of EV engines. Number 6. Solid-state batteries. What are they? Let's begin by comprehending the fundamentals. A liquid or gel-like electrolyte is used by conventional lithium-ion batteries, which power the majority of EVs today, to facilitate ion flow between the cathode and anode of the battery. Despite their effectiveness, these liquid electrolytes have drawbacks like flammability, low energy density, and gradual deterioration. Conversely, solid-state batteries use a solid substance, such as ceramics, sulfides, or polymers, in lieu of this liquid electrolyte. Numerous advantages result from this little but significant modification, such as increased safety, increased energy density, and quicker charging times. Number 5. What makes solid-state batteries revolutionary? There have been enhancements in energy density and range. Why is energy density important for EV battery performance, and what does it mean? The concern that their EV won't have enough battery power to finish a trip is a major issue for EV drivers. SD batteries address this problem quickly. Higher energy density allows these batteries to store more energy in the same volume. Nissan claims solid-state batteries may have double the energy density of lithium-ion batteries. Driving range is greater for EVs. Solid-state batteries may last 600 to 800 miles between charges. Faster charging times. The time it takes to charge an EV is another issue for its owners. The charging time of conventional lithium-ion batteries may range from 30 minutes to several hours. Conversely, solid-state batteries can reach 80% capacity in less than 10 minutes. The user experience is greatly enhanced by EVs' quick charging capabilities, which makes them more useful and equivalent to the ease of filling up a gas-powered vehicle. Increased security. Another area in which solid-state batteries excel is safety. Lithium-ion batteries include flammable liquid electrolytes that may produce thermal runaway, a series of events that can result in explosions or fires. However, since their solid electrolytes are non-flammable, solid-state batteries are intrinsically safer. This gives customers peace of mind by lowering the possibility of disastrous failures. Increased lifespan. Since lithium-ion batteries gradually lose their capacity, battery deterioration is a prevalent problem with modern EVs. Solid-state batteries can withstand more charge cycles before seeing a decline in performance because they are more resilient to wear and tear. This lowers the overall cost of ownership for EV consumers by resulting in longer-lasting batteries and fewer replacements. Number 4. Recent advances in solid-state battery development. Solid-state batteries' potential has drawn substantial research and investment from startups, tech firms, and automakers alike. Let's examine a few of the major forces behind this breakthrough. In the field of solid-state battery research and development, Toyota is a leader. With ambitious intentions to attain a driving range of up to 750 miles and a quick charging time of just 10 minutes, the business hopes to commercialize these batteries by 2027 to 2028. Their efforts could redefine the EV market. Nissan. Another significant contender is Nissan, which is developing solid-state batteries that have the potential to quadruple the energy density of lithium-ion batteries. By 2028, the business wants to launch automobiles using this technology. Honda is working to lower the cost of high-performance EVs by creating all solid-state batteries. With intentions for mass manufacturing soon, the corporation is making significant investments in this technology. Startups and partnerships. Several companies, including Solid Power and QuantumScape, are also making significant progress in this area. For example, QuantumScape has created a solid-state battery prototype that claims to outperform current options in terms of energy density and charging speed. Number 3. Solid-state battery development challenges. Solid-state batteries have undoubted promise, but there are still a number of obstacles in the way of their being widely available. The complexity of manufacturing. Why is it more difficult to produce solid-state batteries than conventional lithium-ion batteries? Compared to conventional lithium-ion batteries, solid-state batteries are more difficult to make. It may be expensive and time-consuming to scale production to meet the needs of the automobile sector, since it calls for new infrastructure and manufacturing techniques. Availability of materials. Solid-state batteries often need more lithium, even if they require less cobalt. Water use and habitat disturbance are two ethical and environmental effects of lithium mining. For solid-state batteries to be scalable, sustainable sourcing will be essential. Scalable performance. Solid-state batteries have shown exceptional performance in laboratory environments. However, it is very difficult to replicate these findings in the real world and on a broad scale. We must solve issues like excessive resistance at the interface between solid electrolytes and electrodes to ensure constant performance. Number 2, effects on the environment. Compared to conventional lithium-ion batteries, solid-state batteries provide a number of environmental benefits. For example, they may be made without cobalt, a substance associated with unethical mining methods and environmental damage. Furthermore, fewer batteries will wind up in landfills due to their extended lifetime, which reduces waste. However, responsible management of the heightened demand for lithium is required. Reducing the environmental impact of solid-state batteries will need the development of recycling technologies and the investigation of substitute materials. Number 1, solid-state batteries' future in EV design. Solid-state batteries have the potential to revolutionize the whole automotive sector, not just EVs. Here's how. We need more compact and effective engines. What effects does solid-state battery technology's ability to create a compact design have on the appearance and performance of EVs? Solid-state batteries' greater energy density enables smaller designs, which frees up room for additional parts or lowers the vehicle's total weight. This creates opportunities for EV designs that are more aerodynamic and streamlined. EV adoption has increased. Solid-state batteries are expected to hasten the global adoption of EVs by addressing important customer issues, including safety, charging times, and range anxiety. By lowering greenhouse gas emissions, this might assist nations in achieving their sustainability objectives. Competitive rates. Solid-state batteries are now more costly to create, but this is projected to change as manufacturing advances and economies of scale increase. A wider audience may be able to afford solid-state batteries, which would increase EV adoption even further. In conclusion, solid-state batteries boost electric car technologies. They may increase energy density, charging times, safety, and the lifespan of current EVs. Despite still facing challenges, Nissan, Toyota, and QuantumScape are making progress that might lead to solid-state batteries. As these batteries become more widely used, they will not only change the fundamentals of EV engine design, but also how we think about transportation in the future. Solid-state battery research is fascinating, regardless of your interest in electric vehicles, EVs, technology, or transportation's future. Like, share, and subscribe for more.